Welcome. In this video, we'll be talking about chemical engineering. What is this field all about and what chemical engineers do? I'll also go into what are the subjects that you study in a typical chemical engineering undergrad major should you decide to pursue a Bachelor of Science or a Bachelor of Technology in this field. I'll also cover what are the future prospects and job opportunities that you have at the end of an undergrad major, and I'll conclude with what are my perspectives on whether you should consider pursuing a chemical engineering undergrad in 2024. So stay right till the end if you're interested in this topic or are potentially a high school student who is deciding for what undergraduate major to pursue. A little bit about myself. My name is Pratyush. I'm a data center engineer at Google Cloud, and I studied chemical engineering for my undergraduate and also pursued a PhD in chemical engineering afterwards. And as someone who has been in this field for quite some time now, I've gained a lot of experiences about this field. And in this video, I would like to share some of my knowledge and perspectives about this field. Let's get started. Now, as chemical engineers, we typically work on converting raw materials to products. And we can think of these raw materials as being something of less intrinsic value to people. But the products, those can be of something of very high value to people. One example of product produced by chemical engineers is gasoline, for instance. We use gasoline to fuel our car every day we decide to drive to work or school. Gasoline is produced by chemical engineers from crude oil. Another well-known example is plastic or polyethylene. That is also produced by chemical engineers from crude oil also. And we use plastic to store groceries or clothes whenever we go to shopping. There are a handful of other examples as well. For instance, detergent that we use to wash our clothes, medicine that we take whenever we feel sick, batteries that we use to power our phones and other electronic devices at home, paper that we use to take notes when we are at school or at home. And this is just a handful of examples. There are perhaps hundreds of other products that are produced by chemical engineers that you use in your own daily life. And in my opinion, this field is quite critical to society and has its own importance and value among other engineering disciplines as well. So how do we do this? How do we convert raw materials to products? And at the core of it, we essentially take some reactions that have been studied well by chemists, both in theory and in laboratory, and we work on scaling up those reactions through chemical plants and chemical processes and chemical reactors to manufacture products at a much larger scale. So as a chemical engineer, we focus on designing these chemical plants, chemical reactors, chemical processes, so that we can run those reactions at a much larger scale and manufacture products at a larger scale to bring to consumers. I would also like to point out one major difference between a chemist and a chemical engineer that a lot of us don't realize and often conflict a chemical engineer with a chemist. And the difference is that as a chemist, we are focused on studying chemical reactions at a smaller scale and gaining a deeper level understanding of those chemical reactions. But as a chemical engineer, we are more focused on scaling up those reactions at a larger scale, because a lot of things that may work on a smaller scale may not always scale to a large degree in real engineering world at a larger scale, and a lot of unexpected challenges may occur during the scale-up process. And as a chemical engineer, we need to work on resolving some of those challenges and be able to run those reactions at a much larger scale to manufacture products to bring to consumers. So there are a lot of things that we need to understand and answer while we consider scaling up chemical reactions from a smaller to larger scale. The first question we need to understand is basically what are the raw materials that we're going to need, and what are the series of reactions that we're going to pass those raw materials through to manufacture products. We need to understand what are the favorable mass, temperature, and velocity conditions for those raw materials, as well as the favorable conditions for the reactions. The next question we need to understand is whether the process is economically viable, meaning that if we were to sell the products to consumers, will we obtain enough profit while also accounting for the cost we may incur to procure raw materials as well as building and operating chemical plants. And one of the most important questions is whether the process is scalable, meaning that the conditions that have been observed to be favorable to facilitate the reactions that we are scaling up, can we replicate those conditions at a larger scale in chemical reactors? A few other things we will need to understand are what will be the types of reactors that we are going to use to manufacture products. Will it be a stirred tank reactor, or will it be a plug flow reactor? What will also be the size of those reactors that we're going to use to manufacture products at our desired target rate? We would also want to understand whether our chemical plant or chemical process of interest have any negative environmental impact in terms of the greenhouse gas emissions. We would also want to know if we can design our process to achieve a high yield in terms of the amount of product produced per unit of raw material consumed. We're also going to want to understand, can we automate the process to run 24/7 with minimal human intervention, meaning that we're going to want to achieve high yield and purity by running those reactors automatically with minimal human intervention, and can we do that using computer-aided tools? As a process engineer at a company in industry, you will likely go through a similar series of questions that I described. Document your analysis, assumptions, and findings in a report or a presentation perhaps. Review that with senior leadership in your company and decide whether or not the company is interested in moving forward with the chemical plant design that you're proposing. Now that we have talked through what is chemical engineering and what are the problems that you may work on as a chemical engineer or a process engineer in industry, I would like to talk through what are the subjects that you typically have to study in an undergraduate major to get trained as a chemical engineer. And the program that I'm going to walk through is just one particular example, and the curriculum that you may go through at your own university may have some slight variations, but the general structure and the flow of the courses will likely remain the same. So the first year is going to be all about building a strong foundation in mathematics, physics, chemistry, and computer programming. And you need to have a solid knowledge of these topics because the subjects you're going to study in subsequent years depend heavily on these. So you will likely take some courses in physics, chemistry, maths, biology, computer programming, calculus, and linear algebra to master your knowledge of these topics. The second year is when you start to really get into some of the foundational and fundamental topics specific to chemical engineers. You will likely take a course on transport phenomena, where you will learn how materials interact with each other and transfer heat, momentum, and mass amongst each other, and how do we describe these phenomena using partial differential equations. Subsequently, in your second year, you may take a course on computational methods that will teach you how to solve those partial differential equations using computer programming methods. There will also be a course on data analysis methods specific to chemical engineers, where you may learn about how to use statistics, machine learning, and other data science techniques to solve problems specific to chemical engineers. Other courses in your second year may include fluid mechanics, where you will learn how to describe momentum balance equations amongst different materials using partial differential equations. There will likely be a course on thermodynamics, where you will learn about different phases of a chemical material, such as solid state, liquid state, and gaseous states, and how those states can be described using mathematical equations. There will also be a course on heat transfer, where you will learn heat balance equation and energy balance equation, and how temperatures of different materials can be described using partial differential equations. All of these subjects in the second year are very foundational and will come in handy when you start to think about designing large-scale chemical plants. In your third year, you will take some more foundational topics specific to chemical engineering and start to gain some practical exposure. So you may take courses such as chemical reaction engineering, solid mechanics, mass transfer, and chemical process control. The chemical reaction engineering course is particularly an important one because this is where you learn how to design and analyze commercial scale reactors. In process control, you will learn how to automate the different pieces of a chemical reactor and how to run reactors 24/7 with minimal human intervention while still achieving high purity and yield for products. You may also have a course on process plant simulation, where you may use a software like Aspen Plus to do a computer-based simulation of a chemical plant that you're interested in. In your third year, you may also start to take up some laboratory courses, where you will build and run a chemical prototype plant at a smaller scale in the laboratory. At the end of your third year, you may also want to take up an internship to gain some practical exposure while working in an industry or doing a research project, depending on what you're inclined towards doing after your undergraduate. The final year is when you combine all of your learnings from years 1 to 3 into an overall chemical process design. You may take up some courses such as chemical process economics, process equipment selection, process design. You may also have some laboratory courses in your final year as well, but for sure there will be a chemical process design project. And in this project, you will have to work through all of the steps involved in chemical process design, depending on the chemical plant that you've selected. You may have to do some computer-based simulations using Aspen Plus. You may do some data analysis to demonstrate the feasibility of your products, depending on the raw materials and reactions that you've selected. You will very likely present your findings and results to your professor, and that will be your overall chemical process design project. Depending on the university and curriculum, you may also have the option to specialize your training into specific chemical engineering areas such as biotechnology, advanced process control, renewable energies, and there could be some more elective choices as well, depending on the specializations that your university has to offer. So that's generally all for what you study in a chemical engineering undergraduate major. And if you're watching this video until now, you might be wondering what comes after the undergrad. So there are typically two options. The first is you get a job straight out of your undergrad, and you could be working as a process engineer, a data analyst, or a biotech engineer, and the median starting salary for fresh chemical engineering undergraduates in the United States in 2024 is about 72,000 US dollars. The other option is you can pursue a master's or a PhD degree in chemical engineering, where you could have an option to specialize your knowledge into some specific areas or take up PhD research in some chemical engineering disciplines such as biotechnology, advanced process control, renewable energies, battery technologies, and there are a lot of other exciting, cool areas that you can do your PhD in. And the median starting salary for chemical engineering PhD graduates in the US is about 120,000 US dollars. And if you're looking for a job after a chemical engineering undergraduate, there are a lot of companies and industries that heavily hire chemical engineers. The first option is to work in the oil and gas industry with companies like Shell, Chevron, and ExxonMobil. These companies heavily hire chemical engineers. The other option is to work in the pharmaceutical or biotech industry with companies like Pfizer, Merck, Procter & Gamble, and Genentech. All these are healthcare and pharmaceutical manufacturing companies that hire chemical engineers. You can also work in the core chemical engineering companies like Dow, DuPont, and BASF. Depending on your interests, you may also decide to work in the food and beverage industry with companies like Nestle and PepsiCo. I would also like to highlight two other industries that people generally don't think of when they're looking for a job after their chemical engineering degree. The first is the semiconductor and electronics industry with companies like IBM, Intel, and Apple. These companies produce electronic chips, and chemical engineering expertise is often required in the process design and manufacturing of these electronic chips. Another option that is also open to chemical engineers, and I'm a part of this industry as well, is the cloud computing industry with companies like Google and Meta. These companies operate data centers to store information online, and the machines inside these data centers generate a lot of heat. And there's an entire cooling plant that is dedicated to removing heat from these data center server floors. And chemical engineering expertise is often quite helpful in the design of these cooling plants, as well as improving other aspects of data center efficiency and operation. Let's talk about whether you should consider pursuing a chemical engineering undergraduate degree in 2024. I think it is one of the nicer paying engineering disciplines, and the starting salaries for fresh chemical engineering undergraduates are quite good. And I think if you like physics, chemistry, maths, and if you think that you may genuinely find subjects like transport phenomena, thermodynamics, mass transfer, heat transfer interesting and exciting, then I think you should certainly consider chemical engineering for your undergraduate major. And there are also a lot of other areas that you can evolve into during your chemical engineering career, such as renewable energy, environmental engineering. And if any of these topics you find interesting and inspiring, then I think you should certainly consider chemical engineering for your undergraduate major. That's all for this video. Thank you for watching. I'll see you in the next one.